So this is something I've gotten a lot better at in my years of teaching. My first year teaching, I kind of blew this off as just another application of derivatives and was like, see, you can do this, and realized we needed to spend a whole day on this one type of application. It's rates of change. It's very similar to velocity, position, acceleration, except it's not velocity, position, acceleration. And so AP does really like these problems. They are very common on question number 1 on the AP open response. So we're going to kind of just work these applications of derivatives. What they do is they give you a rate of change. So they'll say the rate of change of oil leaking from a barrel in gallons per hour. And they'll ask you something about how much oil there is. Well, R of t is the derivative of how much oil there is. Would you agree with that? It's the gallons per hour, how much oil is leaking out of a tanker. So how much oil leaks out of the tanker from time 0 to time 10? And that's the question we're going to answer. And so these are the application problems we're going to look at today in a lot of different contexts. These are very real-world applicable. Y'all remember a few years ago when the oil spilled in the Gulf of Mexico? Well, you would hear them say, well, this much oil has spilled out. The only way they knew that is to calculate how fast it was coming out the pipe and do an accumulation problem. And so this is really applicable. And it's not that much different than what you've been doing. We just need to do a few. So how would you find how much has leaked out from time 0 to time 10? Do the integral from 0 to 10 of the rate now. This one to me looks like a calculator problem because I don't think they're going to make you do e to the 10th power by hand. So type that in the calculator. What do you get? And so based on the answer choices, it must be D. Any questions about that one? Okay, example number 2. Oh, go back up. The flow of oil in barrels per hour through a pipeline on July 9th is given by the graph shown above. Of the following, which best approximates the total barrels of oil that passed through the pipeline that day? Again, pay close attention to units. Barrels per hour means we have a rate of change or a derivative. So if we want to go backwards, we need an integral. We don't have a function. Luckily, they said approximate. So how do we approximate? Area. We're going to literally count squares. Right? Each square is how many barrels? Just out of curiosity. 600. Does everyone see how we got that? So right just with these, and we are going from 0 to 24 because it's that day, so 24 hours. We've got about 2,400 just right here. We're a little shy of 2,400. Does everyone agree with that right here? We're definitely going to get above 2,400 when we add in this stuff. Would you agree this looks like about one more square? So 3,000. Any questions about that one? Okay. I promise I didn't make this problem up. A new car called the Deriver has its plant next to its only dealership. Completed cars are moved immediately to the lot to be sold. Suppose at the start of the month of May, there are 100 cars on the lot waiting to be sold. Cars come off the assembly line at a rate of A of t, and cars are sold at a rate of S of t, where S represents the day of the month for May 1 being T0 and May 31 being T30. Okay. Both of those are rates, would you agree? The rate of the cars coming onto the lot and the rate of the cars going off of the lot. And it says we start with 100 cars on the lot. So how could I find out how many cars are on the lot on May 15th?
You just plug in 15 into the A of T and then subtract 100.
What will A of T give you?
The cars that are sold, or the cars that have come off the assembly line.
The rate of the cars that come off. Okay, I need to do an integral because I don't want the rate, I want the number of cars. I don't want cars per day or cars, yeah, it would be cars per day. I want cars. I want how many cars. So I have to do an integral. Both of them are rates. So anytime you have a rate and you want an amount, you have to do an integral. So I'm going to do 100 plus. Why 100 plus? I start out with 100. And yes, this is enough work for AP. If this is a calculator problem, you don't have to show the antiderivative or anything on a calculator problem. Now, what does 100 plus the integral from 0 to 15 of A of T dt give you? That's all the cars that were put on the lot. What do I have to then do? Subtract how many cars leave the lot in those 15 days. Type all of that in your calculator.
Since May 1 is T equals 0, wouldn't it become 0?
I am glad you're paying attention. Why is it 0 to 14? His explanation was perfect. Starts at 0 and it says May 31st is T30, right? I'm just paying attention this morning. So you'll have to fix that in your typing. Y'all know how to make a quick change like that in your calculator, right? So just change the integral, the top part, go grab it and change it. Didn't anyone do it?
256, but I don't know if it's right.
Okay, so are there more than 100 cars? Yes. The reasoning, part of it's going to be the work I have shown up there, but you could also say more cars enter the lot than leave the lot between days 0 and 15. Because of the way we worked part A, part B is an easy question. Write an equation to represent the number of the cars on the lot. I'm going to call it C of T. You could call it whatever you want. 100 plus, there we go, plus the integral from 0 to T. This is a weird little mental note. If you mess it up, AP will not count it off. They'll call it a spelling error. Technically, you can't have the same variable as a limit and as a variable in your equation. No one cares if you mess that up, but just a weird little technical math notation. So if you were reading a rubric, you would see that. Again, it's not something they would count off for, so don't get too caught up in that. Any questions so far? For time 0 to 30, what is the number of cars? When is the number of cars on the lot a maximum? We do have endpoints, so what kind of justification are we going to be looking for there? Candidates test. I'm going to want C of 0, C of 30, and any critical points in between. Well, where would our critical points be at? And what equals 0? Not quite. Close. When something equals 0. What do we set equal to 0 to find?
It's not the integral, it's the derivative.
It's the derivative of this thing, which is just a of t minus s of t. Wouldn't you agree c prime of t is just a of t minus s of t? And we're going to set that equal to 0. Everyone agree with that? Or in other words, we're going to set a of t equal to s of t. Isn't that what you'd want to know when the number of cars leaving the lot surpasses the number of cars entering the lot? That makes sense, right? The rates, when those would be equal, would be an important place. So in your calculator, you can either do the subtraction equals 0, or you can do the two equal to each other. It makes no difference. I would do that in my y equals screen. So go to y equals and type one side in y1 and one side in y2. Addison, do that with us. You want to make sure you can get that. Again, it doesn't matter if you just set them equal or if you subtract one over and do equals 0, you'll get the same answer. Yes. Calculator skill. Once you get that value in your calculator, remember we are only looking for values between 0 and 30, right? So anything past 0 and 30, ignore. Once you get that value in your calculator, go to your home screen and type X and store it as A or something. Why would I want to do that? I want to keep my answer exact if possible. Now, on this particular problem, because it's only looking for at what time, it's not a big deal, but sometimes they'll ask what is the maximum number of cars, and then we would want to keep that number correct to 3 decimal places. And it will be easier because you won't have to remember it and write it down. So there's two good reasons. Have we gotten this yet? Make sure your calculator is in radians since we are doing cosine.
So if there's more than one intersection,
We want all the ones from 0 to 30. I will listen to 20x goes to it should work either way, whether you did zeros or intersections. It shouldn't make any difference. The only thing nice about zeros is you don't have to worry about setting your Y window because that makes sense. I see 2 intersections. Is that what y'all see? Now, if you happen to do the zeros, you may eliminate one of those 2 instantly because one of those 2 is a relative minimum instead of a relative maximum. So if you did the zeros, it would be easier to point that out. It doesn't matter. If you accidentally check both, it's not a life-changing event. Does everyone know what I mean by that? It is okay if you checked both. 21.043 is one of them. And the other one is 3.309. Is that what everyone got? Which one of those of you who did put it in as a 0, which one of those is the relative maximum? Which one does it cross from above to below? The 21. So if you did it that way, you will not check the 3 at all because you know it's a relative minimum. Does everyone know what I mean by that? The rest of you, will it hurt you if you check the 3? No, it'll be fine. 21 point, I can't remember. What was it? Oh, something.
0.04.
It does need to be accurate to 3 decimal places. 043. Plug all of those into your C function, which is this thing up here. I know 0, don't I? 100. So save yourself the typing space. Plug in 30, plug in 21.043. You can probably go grab from when you typed in the 5 or the 14. You could probably go grab that and pull it down. So after 21 days, the number of cars on the lot starts to decrease. This is actually a pretty realistic problem. Toward the end of the month, car lots do a lot of incentives to sell cars, and they sell a lot more toward the end of the month because they're trying to meet those incentives. And I would probably go ahead and put the 3.309 here. You type XC.
Oh, I can see. I see.
Right, because you saw the, yeah, so type XC. If I were showing my work on a real AP problem, that's probably how I would show my work. Show that C prime equals 0 at those two places, but that's a relative minimum. And then my justification as y'all are working on that is going to be by a candidate's test. What were these values? Has anyone gotten those yet? I only see like one person typing. Everybody get that. Get your calculators going. I could do it for you, but I know how to type it in my calculator. You should probably practice.
354.592.
Is the 30?
Oh, no, it's 21.
Okay, 354 point what?
592.
On this one, you don't have to be accurate to 3 decimal places, but it's just a good habit to be in for if they did ask what is the maximum number of cars. And then what about the 30?
177.754.
So the maximum number of cars is at the 21. Everyone agree with that? By candidates test, maximum cars occurs. There's a lot of different ways you can say this as long as you have this to 3 decimal places somewhere. But you could say occurs at time t is approximately this, or you could, they would also accept if you said something about May 20th, sometime on May 20th. Either way would work. Does everyone know what I mean by that? Just make sure your work is there so that if they wanted the 3 decimal place accuracy, they have it. But you could say something about May 20th. Okay. The cheesesteak factory at Philadelphia Stadium has 25 cheesesteaks ready to sell when it opens for business. It cooks cheesesteaks at a rate of 4 steaks per minute, and it sells cheesesteaks at a rate of 1 plus 6 plus sine of 2 pi t over 41 steaks per minute. For 0 to 20, what time is the number of steaks ready to sell a minimum to the nearest tenth of a minute? Go back to your y equals. You're using t instead of x. So anytime it says undefined variable, there's something in your y equals that it's not recognizing. I don't know. Okay, before I actually ask for an answer, let's talk about what it tells us. What is 4? It is the rate that we are cooking cheesesteaks, so the rate that they are coming in, right? And it is just 4. Now, some of you are tempted to throw a 4x on that. If you do that, you are anti-differentiating, aren't you? So I'm not going to do that yet. So the rate that we cook cheesesteaks, so remember I'm wanting the amount of cheesesteaks to be a minimum, so I'm going to call it A of T for amount of cheesesteaks. I'm making up letters. You can use whatever letter you want. The amount of cheesesteaks, I have 25 cheesesteaks plus the integral of how many come in, right? Minus the integral of how many leave. I am no stadium cheesesteak analyst, but the reason this probably fluctuates, the reason they probably used a sine function there, is probably because at the quarters or halves or whatever the breaks are in the game, you probably have an uptick in how many people buy cheesesteaks, right? Good. So I want, at what time is the stakes a minimum? I'm going to start at 0 and I'm going to go to T. Now, to find the minimum, what do I need to do? From 0 to 20. How do you find a minimum on a closed interval? Candidates test. I need A of 0, I need A of 20, and A of any critical values in between. Correct? I know that A prime, what happens to this 25? Goes away. It's 4 minus 1 plus sine 6. Sorry, I lost a 6. Sine of 2 pi. Do I need to justify on this one? Oops. Do I need to do any justifying on this one? No, it's multiple choice. So I'm just going to type that in my calculator. I'm going to only find the relative minimums. So I'm only going to look for this thing to be crossing the x-axis from where to where? Negative to positive. So I'm going to type this in my calculator, look for it to cross from negative to positive. And that's the other thing I'm going to check. I know A of 0 is 25. I'm going to type 20 up here for the T, and then I'm going to type whatever other critical value I have.
17.0833.
Okay, so I'm cheating. It's either that, or that, right? You see how they've done a candidate's test up there too? They've put all 3 options.
What are you typing in the calculator?
25 plus 0 to 20 on both of those.
What do you need to
To find this. So I'm going to put that in my calculator equal to 0. That gives me the critical value. The 17.1. That makes sense?
How do you equal it to 0 in your calculator?
Put this in Y1 and 0 and Y2 in the intersections. And look for when it crosses from below to above. Now, I am showing you how to do this problem in general. Because this is multiple choice, could you just type all 5 of these in for T? And see which one gives you the smallest number? Yeah, on multiple choice, so if you didn't know how to do a candidate's test, or if you didn't know how to get that critical value, just multiple choice test taking strategy, we could plug them all in and see which one gives us the lowest value. The big deal for today is that we are going to need an integral to get number of cheesesteaks. So what do we get? Type. Don't be spectators. Madison. You're going to get to where you don't know how to type it in. You know what I mean? Okay. Which part? Okay, so what I'm going to do is in my home screen, I'm going to type this top thing right here. Except where the T's are, I'm going to put the 17.1 for one of them and then the 20 for the other one. So I'm going to do it one time with the 17.1 and then one time with the 20. Do you know how I got the 17.1? This equals 0 and the y equals, I put this in y1.
I got 75.814, but I don't know. That's what I got.
Both of you got that, I'd say probably a good thing.
Wait, so are you plugging in the integral one?
Yep.
The top one?
Because I want a of 20, not a prime of 20. I hope that like a prime of 17.1 would be 0. Or close to it, 0.1. Now, on normal problems, I would not want to round the 17.1, but for this particular problem, multiple choice, it's not as big of an issue as open response. 25? 25.227? You would need the decimal on that one because the minimum is at 0. You agree? I never get down below how many cheesesteaks I started with. You see how it could have been any of the 3? Any questions about that one? Yeah. And let's make sure she was right. Did anyone else get a completely different answer?
I got 25.227.
2 pi x over 41 dx. You are in radians.
Every other one I've been getting them, but even up there I did like 20, and still I got like 5.
This, and then it's not like I feel like
You got 6 instead of 1 plus. Can I see your calculator? You got the 25, right? Alright, let's see. Oh, don't do that. Good question. And that's partly my problem right here. Do not put, call that X. Don't put the 17.1 in there, only in for these 2 T's.
okay, A of 20 is 6.8.
Yeah.
So you did them all.
6.8.
See why everyone needs to type?
Why would you read it?
Remember, the t is what we're integrating from and to. This is the function. Remember me telling you earlier, technically we needed to use different variables?
I was wondering.
You see why? Remember I said now AP's not going to count you wrong. They're going to be fine with it. But you have to be careful. If you throw the 17.1 in there before you start, doesn't that make this whole thing a constant? And integrating a constant is not what our game plan is, right? So be careful about that. Now you see why technically AP doesn't like it for you to put a T in both places, even though it doesn't hurt anything if you work it right. But 6 point what?
8
And then what was the 17.1?
3.19116.
Okay, so 17.1 is the correct one. I'm glad I stalled long enough for y'all to figure that out. We probably won't have time to work another one. So let me tell you what your homework is. Tomorrow we will work this AP example. Your homework that is due on Wednesday, so it is not due tomorrow. It's 5 AP problems. So you can see why it's due Wednesday. But 5 AP problems over 2 days is doable. But tomorrow you'll have some work time. Here's the accumulation worksheet. It has 3 AP problems on it. They are recent accumulation problems. Remember me telling you that my first year teaching, I kind of blew this off as, oh, it's just another application of the antiderivatives, but I decided we really needed to just work some accumulation problems to kind of figure out how they work. They are very common real AP problems. Almost every year since I have been teaching, this has been AP open response number 1. So pretty much you can kind of have a heads up to what's coming on AP open response number 1. It's probably an accumulation problem. So anyway, I've got, I think, 5 and 8 on the 6B AP packet, and the accumulation worksheet is due Wednesday. Due Wednesday. So tomorrow will be a work day, and I'm going to work numbers 1 and this population density question. So I'm going to work 2 problems in class, and then we're going to grade the AP from Friday.